Good morning. Today we are learning something new. It's called the Pythagorean theorem. This is a big fancy word that has to do with right triangles, meaning our triangle has a right angle or a 90-degree angle. So first let's talk about our triangles before we talk about our equation. First, every triangle has two short sides, which we call legs. And then the long side is always called the hypotenuse. Those three sides have to do with this equation, a squared plus b squared equals c squared. C squared is always going to be the longest side, which is opposite of the right angle. So here's our right angle. Our opposite side from there, c, is always our hypotenuse. A and b are both legs. It doesn't matter which one's which. This could be a and this could be b. So for example, here's an equation. They say a is 3, so they plugged in that for a. B was 4, so they plugged in 4 there. And here c was 5, they plugged that in there. We knew c was the longest side. From here, we know a squared plus b squared equals c squared. You could prove that by solving that. We're going to now use this equation with one of the sides that's missing. So it says find the unknown length and round to the nearest hundredth if necessary, meaning we're probably going to need a calculator. So if these are our three sides, c is always opposite of the right angle, so we don't know what c is. But the other two sides are a and b. So I say this is a and this is b. So let's use the Pythagorean theorem, a squared plus b squared equals c squared, and solve. So I know a is right here 18, so I'm going to plug in 18 and it's squared, plus b squared, b is really 7.5 and squared, equal to c squared. We don't know what c is, so just leave it as c, but it's squared. So now we're going to simplify. I'm going to use my calculator. Oops, clear. So I can simplify 18 squared. So 1, 8. Now you can push the x squared button to get to the power of 2, or you can use this button here to be to the power of 2. So it's 324 plus 7.5 squared. So 7.5 to the power of 2 gives me 56.25, all equal to c squared. Well, we're just adding these together because there's no variables, there's no letters, so we can just simply add those up. So 324 plus 56.25, we get 380.25 equal to c squared. Now, we don't want c squared, we want just c. So it's the opposite of the power of 2. Just like we know the opposite of adding is subtracting, the opposite of multiply is divide, the opposite of the power of 2 is going to be the square root. A square, power of 2, and a square root are opposites. So to undo this, to get rid of it, I'm going to take the square root. Whatever I do to one side, I have to do to the other. So those cancel out and leave me with just c. It did say round to the nearest hundredth. So I need to plug this in my calculator. See this square root right here? It's yellow. In order to get to that, we need to push the yellow second button, then x squared, there's our square root, and we need to type in 380.25. End your parentheses, and we get 19.5. It said to the nearest hundredth, but there were no other decimals. If you want to put a 0 there, you can. Alright, next we have the same thing, but with square roots. That's okay. We know c is the longest side opposite of the square root, so this side is c. These ones are a and b. Doesn't matter which one's which. So we have our equation. A squared plus b squared equals c squared. Now a is really the square root of 6 squared. B is really y, so y squared. And c is really the square root of 15 squared. Now, because we have a square root and a square, just like back here, those are opposites. They cancel each other out. So those cancel, leave me with just the number 6 y squared we don't know, so it's still just y squared. And those cancel and leave me with just 15. So we need to get y by itself. So I'm going to solve this. I'm going to move that 6 over to the other side, subtract 6. And we get y squared equal to 15 minus 5 would be 10, so minus 6 would be 9. And then just like the last one, to get rid of the positive power of 2, you need to take the square root. So those will cancel out, leave me with just y. And the square root of 9. You can plug this one in your calculator. Some of you might already know what the square root of 9 is. What multiplied by itself gives you 9? Well, 3. 3 times 3 is 9. Alright, let's keep going. These next two are the same thing, but there's just no picture. But that's okay. We can still use a squared plus b squared equals c squared because they tell us, hey, c is 139.4, so we got to square it. A over here we don't know, so we're just going to leave it as a. And b is 123 squared. So I just plugged in a, b, and c. So I'm going to simplify. We have a squared. Then 123 squared, I don't know what that is. 123 to the power of 2. Ooh, big number, 15,129. And then 139.4 squared, 139 and 4/10. Oops, I forgot to square it. 139.4, there we go, to the power of 2. Big number again, 19,432.36. So I know these are big numbers. We need to get a all by itself, so I'm going to subtract 15,129. So those eliminate, and we have a squared equal to something. I'm going to subtract this. 19,432.36 minus 15,129 gives me 4,303.36. And now our very last step, to get rid of this power of 2, we need to take the square root. So those will eliminate each other and leave us with just a. And then we need the second square root of 4,303.36. 65.6. Now, they won't always be nice numbers or not decimals that go on. But if they are decimals that repeat or go on, you can round it to the nearest tenth. Alright, next one, let's use a squared plus b squared equals c squared. We know a is the square root of 8. So we have the square root of 8 squared. Notice this whole thing is really squared, so it's not 8 squared, it's the square root of 8 squared. B is 1, so 1 squared. And c we don't know, so we'll leave it as c squared. So when we have the square root and a square, opposites cancel each other. We just have 8. Let me try that again. 1 squared, it's not 2. 1 times 1 is still 1. So we have 8 plus 1 is just 9. And then last, to get rid of the square, we need to take the square root. Those cancel. Leave with c equals the square root of 9. We did this one earlier. 3 times 3 is 9. So that's the unknown length. Alright, our last step here, or last set of problems before we do one challenge problem, is identifying right triangles. It says this is the converse of the Pythagorean theorem. This is not shoes. Converse means the opposite. So the Pythagorean theorem says that if it's a right triangle, then a squared plus b squared equals c squared. Now they're telling you the converse, or the opposite. Well, if a squared plus b squared is c squared, then the sides must make a right triangle. So they're just flip-flopped of each other. So they're giving us all three sides. We need to decide, do they make a right triangle or not? So of these three, C is always the biggest side, so I know this side is C. These ones, it doesn't matter. You get to choose which one you want to be A and which one you want to be B. So let's plug these into our Pythagorean theorem. If you don't need to write this, that's okay. If you just want to plug in 6 and make it 6 squared, plus B squared is 8 squared, C squared is 10 squared. So 6 squared, or 6 times 6 is 36. 8 squared, or 8 times 8 is 64. And 10 squared, or 10 times 10 is 100. So we just need to add these two together. If you're not sure, you can use a calculator. 30 plus 60 is going to be 90, and 6 plus 4 is 10. So 90 and 10 more is 100. 100 does equal 100, so yes, this is a right triangle. Let's try another one, same thing. Here's A, B, and C. They already have them there for you, so we're going to do A squared, or 10 squared, plus B squared, which is 12 squared, equal to C squared, which is 16 squared. Hopefully you know this first one. 10 times 10 is 100. If you don't know 12 times 12, that's okay. You can use your calculator, or 12 squared here gives you 144. And then 16 squared. 16 to the power of 2 gives you 256. So we need to add these two together. 144 plus another 100 would give you 244. So clearly we can see that those are not the same. So no, this is not a right triangle. Alright, our last problem on Pythagorean theorem. It says find x, not just find it, find the length of x, this side. So this side has to do with, oops, this was bad drawing, but this triangle right here. Of that triangle, we don't know this side. We know this side's 14, but we also don't know this side. So we can't use the Pythagorean theorem for that triangle yet. However, we do know we have two sides of this triangle. So one thing that you do know is that you have two sides of this triangle. I'm not going to write that right now. I'm going to look at my other questions. It says, are there any formulas that would be helpful? Well, what kind of triangles are these? We know we have right triangles. If we have a right triangle, well, what formula would help us then? Well, we know a squared plus b squared equals c squared for right triangles. And we are trying to find x. Right now, first we're going to find the missing side. Then we're going to find x. So if we know a squared plus b squared equals c squared, we know a, b, and c. Let's plug those in here for just this bottom triangle. C has to be the longest side, which must be 12. A and B, it doesn't matter. So I'm going to say this is A, and this side is B. So A is just A, we don't know, and B is 6. So we have A squared, which is really still just A, we don't know what it is. B is really 6 squared, equal to 12 squared. So again, A squared we don't know. 6 squared, or 6 times 6 is 36. And 12 squared, hopefully you maybe know this one. 12 times 12 is 144. So let's take a look here. We need a squared by itself, so I'm going to move this 36 over to the other side. So we have a squared equal to 144 minus 36. Should give us 108. If you're not sure, type in your calculator. 144 minus 36, 108. So we need not a squared, we want just a, so we need to take the square root on both sides. So those will cancel. However, we're going to use this side length to find another side length. So we don't want to guess, because if I plug in the square root of 108 into my calculator, well, that's not going to be a very nice number to plug in for x over here later. So we're going to leave it as the square root of 108 for right now. So over here, this side we just found out is the square root of 108. So now we can find, we have this side, we have this side, we can now find the missing side length over here. So we're going to do the Pythagorean theorem again for this second triangle. So C has to be the longest side, 14. So I'm going to put 14 squared. A and B, it doesn't matter. I'm going to say this is A, so it's really the letter X now. And B is really the square root of 108. So square root of 108, but it's squared. So I have X squared. The square root and the square cancel here and leave you with just 108. And then 14 squared, 14 to the power of 2 gives me 196. We're just doing the Pythagorean theorem again to figure out the side of X. So I need to get rid of this 108. I'm going to subtract 108. So those eliminate, and I have X squared equal to, well, 196 minus 108. Again, if you're not sure, type it in your calculator. Should give us 88. And then last, the opposite of square is the square root. So square root of 88, not going to be a nice number, so I'm going to plug it in. The square root of 88 is about 9.38, or if we round up, 9.4. So we had to do the Pythagorean theorem 2 times, one for this bottom triangle and then one for the top time. Alright, our second mini lesson today is simply on exponents, and then we are done. So some of you still have not finished your quiz on exponents, so that would be a good idea to do today, in case you have not done so to improve your grade. So first, we need to count up how many 7s there are. We're simplifying, remember. We are not solving, no calculators here. So this 7 to the power of 3 is 7 3 times. And this 7 to the power of 5, the exponent is 5. That's 1, 2, 3, 4, 5 7s. So total we have 1, 2, 3, 4, 5, 6, 7, 8 7s. So 7 multiplied 8 times. Same thing here, but with x's. This is 4 x's. Exponent tells you how many you have. This is 3. So we have a total of how many x's? Well, 4 plus 3 more is 7. Same thing here. Don't let this trick you. These are touching. This really is multiplied just like these were multiplied. This is just 1 negative 5, and this is 6 negative 5s. So if that's 6 and 1 more, that makes negative 5 7 times. So if the exponent tells us how many times to write whatever's there, this outside exponent tells us we need to write x squared 4 times. X squared, x squared, x squared, x squared. So each of these is really 2 x's. 1, 2, 1, 2. So total we have 2, 4, 6, 8 x's, or x to the power of 8. Alright, this next one, it says we need to write whatever's in parentheses 2 times. 2x to the third, 2x to the third. So because there's not any more parentheses, we can just write out what we have. We have a 2, and then 3 x's. We have a 2 and 3 x's. This 2 doesn't really have an exponent. There would really be a 1 there. There's 1 2 there. So total we have 1, 2 2s, so 2 to the power of 2. And 1, 2, 3, 4, 5, 6 x's. X to the power of 6. Now if this is a small exponent like 1 or 2, you can just simplify it. 2 squared, or 2 times 2 is 4. And then there's still x to the 6. Alright, this next one, these square parentheses we call brackets. It's just another way to show parentheses. So the outside exponent tells us how many times we write it. So we're going to write this 1, 2, 3 times. We're going to write negative 6 squared. negative 6 squared, negative 6 squared, 3 times. So then we need to figure out, well, how many negative 6's are there really? Each one of these is really 2 negative 6's, because the exponent is a 2. So how many negative 6's do we have total? Well, 2, 4, 6. So our answer is negative 6 to the power of 6. All right, last slide. First, we have whatever's in parentheses, we're going to write it 2 times. 10x to the power of 6, 10x to the power of 6. This, we just have 1 time. We have 1 x to the power of 2. So we're going to count up how many we have of each thing here. We have a 10 and 1, 2, 3, 4, 5, 6 x's. A 10 and 1, 2, 3, 4, 5, 6 x's. And here we just have 2 x's. So first I'm going to count up my numbers. I have 10 2 times. So I'm going to write 10 to the power of 2. If you want to evaluate that, 10 times 10 is 100. That's fine. And then count up all your x's. 6 plus 6 plus 2 more. Well, 6 plus 6 is 12. 13, 14. So we have x to the power of 14. So either of these would be correct answers. Last one like this, we're going to write whatever's in parentheses 3 times. 9xy, 9xy, 9xy. So here we have 9, 1, 2, 3 times. We have x, 1, 2, 3 times, x to the third, and we have y 3 times. You need to have each one have the exponent. All right, last part here, find the missing exponent. If we need to get 12 x's total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need to get 12 total, and they're giving us 6. How many more do you need to get to 12? Well, 6 plus 6 would give you 12. So your question mark, we would need 6 more x's in order to have a total of 12. All right, next one, again, we need 12 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I know we have a group of 4 x's, so this is one group together. How many groups do we need to get to 12? Well, if you think of groups of 4, you would need 1, 2, 3 groups of 4. If you want to write it out 3 times, you can, but don't think 2 more. How many total? We would need 3 total groups. All right, last one. We need to get to the number 27, and then 18 z's. Instead of writing out z 18 times, I'm simply going to represent each z by a dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So here, I don't know what's in my group, but I know I have 3 groups. So I'm going to symbolically draw out 3 groups. So now I know each group has a 3. How many z's do I need in each group to get to 18 total? Well, if there's 3 groups, I actually set mine up pretty nicely here, so I could figure out how many we would need in each group. So here's 3 groups. If you split them, there's 1, 2, 3, 4, 5, 6. 6 times 3 is 18, so that makes sense. We would need 6 z's in each group. So the question mark, we needed 6 z's in each group to get to a total of 18 z's. All right, your homework. The front side is Pythagorean theorem. You get to move your football helmet 10 yards down the field when you complete this side. Here is the formula that you're going to be using as well. These ones, this one is like the last problem we did, so be careful on this one. And then on the back side, you get 5 additional yards for simplifying these ones. Good luck. Let me know if you have any questions.